you've got cosine formulas in the middle and then tangent at the bottom. All of those are the same. Okie doke. So I'm not going to spend much time on that. You don't have to put those back down. Let's get right to the directions here. It says find exact values of sine, cosine, and tangent for each. Find exact values of sine, cosine, and tangent for each. These actually are the same directions that you had at the end of the lesson yesterday. That was what the end of the assignment was like too. They gave you something, you had to go through sine, cosine, and tangent. Now, there's one big difference though between what we did yesterday and what we're doing today. I put this warning up here just to tell you that there are going to be lots of ways to do these problems. Now, I'll come back to that warning here in just a second. Let me show you why there are so many different ways that you could do these problems. If you look at example 1, all they're giving you is 15 degrees. Now, I have to find sine, cosine, and tangent of 15 degrees. But hang on a second. If I look at handy dandy, is 15 degrees in your table? No. And we're not allowed to just type this into our calculator because we are supposed to find exact values. So, because it's not on handy dandy, and I would probably write this down in my notes, we have to find our own pair of angles that equal 15 degrees. We have to find our own pair of angles that equal 15 degrees. Okay, they can either add up to 15 or they could subtract to equal 15. Now, you don't want to just pick any old angles. You want to pick angles that are on handy dandy. That way, later on in the problem, I can actually use my table to evaluate. So, once again, 15 degrees is not in the table. Now, because the next smallest angle is 0, it's going to be impossible to use two angles off of here that would add to 15. I usually try the sum first because it just seems a little bit easier. But you can't take two angles up here that add up to 15, which means we're going to have to find two angles up here that would subtract to give you 15. Now, here's where the warning comes into play. There's a lot of angles up here that would subtract out to give you 15. Now, what I saw first was right here. 45 minus 30. What is 45 minus 30? 15. Now, that's what I picked, but I didn't have to pick those two. I could have picked 60 and 45. 60 minus 45 is 15. 135 minus 120 is 15. 225 minus 210 is 15. There's a lot of different ways that you could set this up. But to keep us all on the same page here, let's all pick 45 minus 30. That is how I'm going to start this problem. I'm going to say 15 degrees equals 45 degrees minus 30 degrees. If you had picked two other angles, we should still get back the same answer. Now, the answers could be slightly different, like they could look slightly different. So that's where, like tomorrow when I read off the answers, it's going to be kind of tricky because it all depends on what angles you started with. So now the directions, and I have to find sine of 45 minus 30, cosine of 45 minus 30, and tangent of 45 minus 30. So let's just start with sine. I think in the notes yesterday I put sine on both sides, but you probably caught on that we don't really need the left side too much. We're just working over here. Okay, I see the sine and I see the minus. So if you look at those formulas that we have from yesterday, you want to match this up to the sine of u minus v formula. This is why I printed them out so you didn't have to flip back and forth a whole bunch today. That formula says sine of u, which would be sine of 45 for us, cosine of v, which is 30 degrees, minus cosine of 45, sine of 30. And to be honest, from this point on, everything else about this problem is exactly the same as yesterday. The only difference today is this part right here. You have to find your own pair of angles. So here we go. Sine of 45, that's radical 2 over 2. Cosine of 30, that is radical 3 over 2. Minus cosine of 45, which is radical 2 over 2, times sine of 30, which is 1/2. Now we just have to multiply and simplify. Square root of 2 times square root of 3, that would be square root of 6 over 4, minus, that turns into square root of 2 over 4. So, putting that all together, anytime you have the common denominators, then just put it as a single fraction. That would be it for sine. Okay, moving on to cosine of 45 degrees minus 30 degrees. Stop me if you have any questions, but all of this right now is the same as yesterday. I'm matching this up to the cosine of u minus v formula. And here it is. Cosine of u, that's cosine of 45, times cosine of 30, plus, which always seems backwards, it's the opposite of what you had over here, plus sine of 45 times sine of 30. Now, handy dandy will be helpful right here, or you could actually look back at the numbers you found earlier. They're just in different spots. Cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Plus sine of 45, which is radical 2 over 2, times sine of 30. Everything is positive here. That's good. So square root of 6 plus square root of 2, we're going to put that all over 4. Okey-doke. Now, any questions about cosine? We're looking good here. Last part is tangent. And remember, don't try to simplify too much on tangent. Those answers are just always going to be a little bit weird. And so I'm looking at the tangent of u minus v formula. It should be the very last one on that list. Okay, tangent of u, that's tangent of 45, minus tangent of 30, all over 1 plus tangent of 45 times tangent of 30. Let's look these up real quick. Tangent of 45 is 1 minus tangent of 30, which is radical 3 over 3, all over 1 plus tangent of 45, which is 1, times tangent of 30, which is radical 3 over 3. You need to multiply these two numbers together, but anything times 1 is just that thing. And again, you don't have to go any further with that. You can just leave it the way it is. If you really don't like the fractions in a fraction, you can just take all of those terms and multiply by 3 if you want. You don't have to do this. But take everything times 3, and this is now 3 minus square root of 3. The 3's would cancel right there. All over 3 plus the square root of 3. That would fix the fractions if you want. You don't have to, but that's probably more what the book would have. Okay, any questions about example 1? You had to find your own pair of angles that equaled 15. Now this one was in degrees, which in my opinion is probably the easiest type of problem when it's in degrees. We also are going to have some in radians, and these are not as easy to think about. So I need you to watch carefully up here about how I come up with my pair of angles that would equal 5 pi over 12. If possible, I like to find a sum that equals this number. It's just easier to think about. We couldn't do that on the first example because 15 was so small, but I think we'll be able to find a sum pretty easily right here. Now again, this is not as easy to think about because first of all, it's a fraction, and second of all, it has pi in it. So that always kind of throws us off. Okay, so watch here for a second about how I like to think about it, and if this doesn't work for you and you find a different way, that's perfectly fine. But this is what I like to start out doing. This is 5 pi over 12. Why don't you go back a little bit for just a second and start with 1 pi over 12. You may want to write this stuff somewhere on the side. I'll have to erase it here in a minute, but this is kind of helpful for how you come up with this pair of numbers. Okay, if this is 1 pi over 12, 1 pi over 12 plus what would equal 5 pi over 12? You know you need a 12 on bottom, so 1 pi plus 4 pi would equal 5 pi. Let me put that 4 pi up there. Now, the whole point of this is to find a pair of angles on handy dandy. All right, now this actually would work out okay. This fraction, if you divide by 4 on top and bottom, that would turn into pi over 3. Is pi over 3 on your table? Yes, but is pi over 12 on your table? No. So you don't want to use that pair. It's not going to match up to handy dandy. So we started with 1 pi over 12. Let's move on to 2 pi over 12. Okay, 2 pi over 12 plus what would equal 5 pi over 12? 3 pi over 12. You know you need a 12 on bottom. Anytime you add or subtract fractions, you have to have a common denominator. And 2 pi plus 3 pi gives me 5 pi. Now let's think about these fractions. If you divide by 2 on top and bottom right here, that's the same as pi over 6. Is pi over 6 on our table? Yes. Divide by 3 on top and bottom over here, and you get pi over 4. Is pi over 4 on our table? Yes. So this is, and I'm not going to use these fractions. I'm going to use the ones that have been reduced, we always want to reduce, of course. So I'm going to say 5 pi over 12 equals pi over 6 plus pi over 4. That is how my brain works on this problem. That's how I come up with a sum of numbers that equals 5 pi over 12. Any questions about how we got those? Not as easy to think about as degrees, but now we can go ahead and start the process. Sine of pi over 6 plus pi over 4. And by the way, if you had the order of those switched, it would be okay because addition is commutative. If you put pi over 4 plus pi over 6, our answers should still be the same. All right? Now, this is sine of u plus v. So sine of u, cosine of v, plus cosine of u, sine of v. I need to look all of these up real quick. Sine of pi over 6 is 1/2. Cosine of pi over 4 is radical 2 over 2. Plus cosine of pi over 6, which is radical 3 over 2, times sine of pi over 4, which is radical 2 over 2. We need to multiply and simplify. This is radical 2 over 4 plus radical 6 over 4. And putting those together, it will be radical 2 plus radical 6 all over 4. We're looking good. Now cosine of pi over 6 plus pi over 4. Here we go. This is the cosine of u plus v formula. I've got cosine of pi over 6 times cosine of pi over 4 minus sine of pi over 6 times sine of pi over 4. And I found all those numbers earlier. Cosine of pi over 6 is radical 3 over 2. Cosine of pi over 4, that is radical 2 over 2, minus sine of pi over 6, which is 1/2, times sine of pi over 4, which is radical 2 over 2. And so this one ends up being square root of 6 minus square root of 2 all over 4. Okay, questions about cosine? Almost done here. Last one we have to do is tangent. So we're on our way. Tangent of pi over 6 plus pi over 4. Here it is. I gotta take tangent of pi over 6 plus tangent of pi over 4 all over 1 minus tangent of pi over 6 times tangent of pi over 4. Okay, well, tangent of pi over 6 is radical 3 over 3. Then tangent of pi over 4 is 1 all over 1 minus tangent of pi over 6, which is radical 3 over 3, times tangent of pi over 4, which is 1. And you can go ahead and multiply those out since it's just 1. Square root of 3 over 3 times 1 is just square root of 3 over 3. You don't have to do anything else. It doesn't simplify to just be a 1. You could take everything times 3 and it would be radical 3 plus 3 all over 3 minus radical 3. That's fine. Or you can just leave it the way it is. Okie doke. Questions on that? Some of your problems are in degrees, some are in radians. Now, there is something pretty important I need to show you about a couple of these problems. So go ahead and copy this assignment down. It's T41 from page 381. We're doing 19 to 25 odd. Keep in mind, if you pick a different pair of angles than the book, your answer could look slightly different. So you should be able to check these, but keep that in mind. And also, of course, show your work on these so I know how you got started. And I want to show you something real quick about number 21 and also maybe something about 25. Let me put this up here real quick, and you'll want to hear this because we didn't really run into this in the notes. I'll let you get that started here real quick. 21, I'll put part of it up here with you. Okay. It says negative 105 degrees. Negative 105 degrees. We didn't have any negatives in our notes today. And I guess it's possible, I don't know on this angle, but maybe on some angles you could find a couple other angles that would subtract to give you a negative. That might work, but I don't know if it works too well on this. So what can we do if we have a negative angle but we want an angle in the same position that's positive? Coterminal angles. Let's add 360 degrees to that to make it 255 degrees. Now you can look for a pair of angles that would add up to 255. I'll let you finish that part. But then if you go to number 25, it's another negative. It's negative 7 pi over 12. And this is in radians. So do you remember what to add for a coterminal angle in radians? 2 pi. Now, the 2 pi, you may have to rewrite a little bit so you have common denominators. Think of that over 1, multiply by 12 on top and bottom, and that would turn into negative 7 pi over 12 plus 24 pi over 12. And then if you go ahead and subtract that out, that should be 17 pi over 12. So I'll leave you that next part, but you can find a couple numbers that add up to that. You may have to kind of make a list out, like I showed you in the notes. Radians take a little bit longer to do than degrees.